Hi, we are group C5 and we are going to be presenting how students develop mastery.
So the reading opens with two professors who are wondering why students in their classes aren't as prepared as they assumed that they would be given their prerequisite courses that they'd taken. And one professor is wondering why they're not able to produce really nice group work because their individual projects are really good, and wouldn't it be better to have even more people with those skills working together? And the other professor is wondering why these students who have taken the proper prerequisites for this class aren't able to carry over those skills. And so these two professors are thinking about mastery in terms of its definition as the attainment of a high degree of competence within a particular area. But they're actually asking for more than they realize from these students, because they're asking them to apply these skills into new contexts and to use multiple skills that they've learned individually all at once. And so the real principle of learning that's at work here that we really need to focus on for these students is how to develop that mastery in terms of acquiring component skills, practicing integrating them, and knowing when to apply what they have learned in the correct context.
So looking into what the research tells us about mastery, in the following slides, we'll explain why expertise may pose as a problem for educators, and then we'll explore each element of mastery, and then finally we'll go into the implications for teaching. So the problem with expertise is the expert blind spot, and this is when well-mastered instructors are blind to the learning needs of a beginner or novice. And then the elements of mastery are in this photo on the right here. The first element being acquiring component skills, which is just the building blocks of complex skills, and then practice integrating skills, which is just the recomposition of complex skills to integrate within the complex of the larger task, and then knowing when to apply skills. So this is when and where to use what students have learned. And then lastly, the implications for teaching consists of various strategies suggested from research to aid in mastery development, which will be talked about later.
So we're just going to pause for a moment here so that you can process the concepts that we've introduced so far, because as we're teaching you about this principle of learning, we want you to master it and use the skills that we're teaching to learn the skills that we're teaching, if that makes sense. So
The first component skill is about understanding the levels of expertise. These are shown in the models of mastery as 4 stages focused on competence and consciousness. Each stage is described and shown in the graph below, and these stages range from unconscious incompetence, where the novice student has no developed skills or knowledge of what needs to be learned, to the expert with unconscious competence, where a skill is exercised so automatically that they are no longer aware of what they do. This leads to the expert blind spot, which was discussed previously, where instructors can underestimate time needed for students to complete a problem and overestimate students' ability. The expert blind spot can be reduced by focusing on the acquisition of key component skills, the practice in integrating them effectively, and knowledge of when to apply what they've learned.
Component skills are individual abilities that can be combined to perform many more complex tasks. And often these individual skills can involve cognitive skills that aren't visible. If a student is lacking a component skill needed to complete a task, the task performance can suffer. And Lovett shows this in his 2001 study, where when students are lacking one of 2 key statistics skill, the overall ability to complete the statistics task was compromised. To identify component skills and improve overall teaching of complex skills and tasks, instructors need to be able to decompose the complex tasks. This can be easier said than done, since expert blind spots can make a component skill seem like intuitive second nature to the professor. Once the component skills have been identified, there should be focus on them to improve overall performance. If the task is highly complex and can be easily divided into the different component skills, they should be practiced in isolation. But if the task is fairly simple or not easily divided, they should be practiced in context of the task.
Mastering complex tasks need people to integrate component skills. Many studies have shown that people perform worse when they are asked to do more than one task at a time because doing multiple tasks simultaneously require attention to more information. Cognitive load of multiple tasks happening at the same time may exceed people's limit so that they don't have other cognitive resources to complete the task effectively. For example, people drive worse when they are answering a phone call because answering phones require people's attention. However, experts do not suffer from performing complex tasks because they have practiced the component skills a lot and the skills need fewer cognitive resources for them. So instructors do not experience same cognitive load as students do, which lead them to have really high expectations for students. To help students, instructors can allow students to focus on one skill at a time. For example, let the students learn to use spreadsheet and then use it to learn math instead of learning the two skills at the same time. The instructors can also do scaffolding, which means to support students do some aspects of a complex task so that students can focus on certain dimension of learning. For example, they can provide formula cheat sheet on the exam.
In addition to component skills and integration, mastery also requires application, and specifically transfer is the applications of skills in one context to a novel context. So transfer is said to be near if the contexts are similar, and far if there's different knowledge domains or different kinds of contexts. Transfer is neither often nor automatic, and the more dissimilar the learning and transfer contexts are, the less likely successful transfer will occur. Reason why students fail to transfer is over-specificity or context dependence is where students associate knowledge too closely with the original context. And also when students have incomplete understanding of underlying principles and deep structures, students know what to do but not why. Tips on how to bolster transfer is to combine concrete experience and abstract knowledge or principle and apply them in multiple contexts, as well as structured comparisons, compare and contrast different kinds of scenarios and identify deep features. Some practices also include analogical reasoning, visual representations for features and patterns, and articulating causal relationships. Finally, minor prompts from instructor can also help transfer because instructors can ask students to think about application to a different context. In addition, teach for transfer is when students need to reinforce understanding of deep structure and principles, provide a diverse context for application, and help students make connections between skills and contexts.
Now we would like you to take a few minutes to pause the video and practice integrating the skills you have learned. For each of the following scenarios, please consider the possible blind spots you may have, identify the component skills your students will need, assess the cognitive load required to complete each task, and compare the context at hand so students have experienced. Now, these strategies can be applied in various teaching situations to integrate the elements of mastery. The first category of strategies is to help decompose complex tasks to build student skills more systematically and diagnose areas of weakness. This includes pushing past your own blind spots, consulting others about effective methods, and diagnosing weak skills and providing practice focused on them. The second category is strategies to help students combine and integrate skills to develop greater authenticity and fluency. This includes temporarily constraining the scope of the task, having students practice to increase fluency, and including integration into performance criteria. The final category is strategies that help students learn when to apply what they have learned or facilitate transfer. This includes having students identify and apply relevant skills and knowledge to different contexts, discussing and providing prompts regarding conditions of applicability, and asking students to generalize larger principles.
Thank you very much.